Hello everyone. This is a problem involving flux calculation using the concept of solid angle. A point charge plus Q is placed on the axis of a closed cylinder of radius r and height 25 r by 12. Actually it should be length, this length it is talking about. This length is 25 r by 12. If the electric flux coming out from the curved surface of the cylinder is x times q by 10 epsilon naught, we have to find the value of x. Actually, we know that if we consider any closed surface, the total flux coming out of the closed surface is q by epsilon naught. And here we have three surfaces, two circular surfaces, one on the left, one on the right, and the curved surface of the cylinder. And we know that any circular surface, or in fact any surface, will subtend a conical volume at any point charge. And if we know the two-dimensional angle phi, or let us take theta, then the solid angle denoted by capital omega is related with theta as 2 pi 1 minus cos theta. And in fact, if we directly talk about flux, then the total flux coming out of this surface due to the charge q, total flux coming out of this surface is given by q by 2 epsilon naught 1 minus cos phi. You can easily derive this equation using unitary method, because total angle subtended at a point charge is 4 pi, total solid angle 4 pi, and 4 pi corresponds to q by epsilon naught flux. So any solid angle phi will correspond to this much of flux, q by 2 epsilon naught. So let us start with the problem. Total flux coming out of the all the three surfaces will be q by epsilon naught. So this will be equal to the flux coming out of the curved surface of the cylinder, that is x times q by 10 epsilon naught, plus the left cylinder, the left circular surface of the cylinder and the right circular surface of the cylinder. Now what we have to do is only calculate the two-dimensional angles subtended by the circular surfaces at the charge q. So I have already taken the diagram. Let us zoom it slightly, and we will use simple geometry here. This charge, the surface will be subtending a cone like this. So if this angle is let us say theta 2, then we can easily calculate cos theta 2 here. This is r. So this longest side will be under root of r square plus 3r by 4 whole square. And if we solve this value comes out to be 5r by 4. So cos theta 2 we can directly write as the base is 3r by 4 and hypotenuse is 5r by 4. So this will be 3r by 5r. 1 by 4 will get cancelled. So cos theta 2 directly comes out to be 3 by 5. Similarly, the left circular surface will also subtend a conical volume like this, and this two-dimensional angle theta 1, let us say. So this cos theta 1 we are interested to find out. So this longest side, hypotenuse, will be again under root r square plus 4r by 3 whole square, and this value comes out to be 5r by 3. So we can easily calculate cos theta 1. cos theta 1. This will be 4r by 3. This is the base 4r by 3 and divided by 5r by 3. So 1 by 3 will get cancelled. So we will get 4r by 5r. So that is 4 by 5. So from this first equation, let us proceed. We can write q by epsilon naught equal to x times q by 10 epsilon naught plus phi 1. If we use this formula, sorry, this angle should be theta. This angle should be theta. Let us take this angle as theta. So phi 1 can be written as q by 2 epsilon naught and 1 minus cos theta 1. Cos theta 1 is 4 by 5. Similarly, phi 2, the flux coming out of the circular surface on the right, that will be q by 2 epsilon naught 1 minus cos theta 2, that is 3 by 5. So we can solve it. Let us cancel out. Q by epsilon naught will get cancelled. Q by epsilon naught will get cancelled. So 1 we will get here. So 1 equal to x by 10 plus 1 by 2 and 1 minus 4 by 5 will be 1 by 5 plus again 1 by 2 and 1 minus 3 by 5 will be 2 by 5. So we are getting a 10 in all the denominators. So we can cross multiply by 10 or multiply by 10 on both sides. So 10 will be equal to x plus 1 plus 2, or from here we get the value of x as 7. So that is answer. We were asked to find out x. So you can go through once. In fact, any surface, not only circular surface, if any surface, if you join all the points on the surface, all the points on the periphery of the surface to any charge q, it will be subtending a conical volume. And the two-dimensional angle theta is related to the solid angle phi by this equation. And from there we can calculate the flux also. Flux will be q by 2 epsilon naught 1 minus cos theta, and then we have done the flux conservation. Total flux coming out of all the closed surfaces will be q by epsilon naught, and then this is simple geometry, simple mathematics, and we get x equal to 7. That is it. I hope you get it. Thank you.